Again, sorry, Mr. Rujo, my phone ran out of storage again, and I had to delete some storage. Anyways, so I moved on a lot, and I'll just quickly explain it again. So we found that we left out, I think, at h of 8, and we know that now that it says find the amount of water in the container at t equals 8 minutes. We do h of 8 equals to h of 0, time equals 0, which is 500 gallons of water, plus the amount that's being poured into or pumped into the container, which would be represented by the integration of 0 to 8 of f of x, minus, since it says water is being drained out of the container, represented by the function of g of x equals 17x squared plus 8, minus the integration of 0 to 8 of g of x, which equals to 5,209.334 gallons of water at t equals 8 minutes. For question part 2, it says, in the context of the problem, explain the meaning of integration of f(x) from 0 to 12 minus integration of integration of g of x from 0 to 12. So, essentially, the integration of f of x dx from 0 to 12 minus integration of g of x dx from 0 to 12 represents the amount of water poured into the container from times t equals 0 to t equals 12 minutes, subtracted by the amount of water drained from the container from times t equals 0 to t equals 12 minutes, which will give you the amount of water that's currently in the container at t equals 12 minutes. Without the addition of t equals 0, which is be 500 gallons of water. And last but not least, we have volumes of rotation. So basically, volumes of rotation helps you find a 3D area of a object with the use of a 2D graph. So let's say that we have, and there's two ways to find volumes of rotation. There's this method and washer method. So in this case, this is our 2 disk areas, which R was the area that we're trying to find. And let's say the R is being rotated over the y-axis. Right? Y-axis. Yeah. So you know that the function is of this right here is y equals negative 7x squared plus 8. And so in order to find the rotation of this, we do the pi times integration, and we need borders. And since we're doing the integration of this from, the rotation of this from the across the y-axis, we do the, is it x or y coordinate? We do the y coordinates. So let's case this would be 0 and 8. So from 0, so pi times the integration from 0 to 8, system view, okay, make sure, of r, which in this case is also y. So negative 7x squared plus 8 squared dx. The formula for this is pi times integration of r squared dx. So plug this into a calculator. Pi times integration from 0 to 8 x squared plus 8 squared dx, which equals to a whopping number of 9,406.338. I'm going to double check that number. Wait, sorry. Since we're rotating over the the y axis, we use the x coordinates. Sorry about that. That's where it went wrong. So let's say that this is 4. So the new equation is pi times integration from 0 to 4 of r, which is negative 7x squared plus 8 squared dx. Which yields 2,482.446. It says units aren't specified. That's just basically the area. And let's say that for this one, since we're going over the x-axis, we use the y-coordinates. So let's say it's from 0 to, let's say, 17. How about that? And then we do the integration problem. Or volumes by rotation formula. Pi times integration from 0 to 17 of y, which is also r in this case, evx squared dx, which equals to 17 evx dx. Wait, am I doing this wrong? If you do it from here to here, and you do it from here to here, and you're going over the x-axis, why use y-coordinates? Because that would just give you, it will give you this. If you do from here, you have 0 to 8 versus 0 to 4. And this one's a really big number. 0 to 17. Remove the y-axis, the x-axis, it would be like over here, it needs somewhere over here. Sorry, Mr. Boudreaux. What's this? Oh, okay. All right, sorry, I had it all wrong. Okay, so for this one, it is the y coordinates. That's what really threw me off. Okay, x. So this is unneeded. This is also unneeded. So let's say that it must stop at, let's say, 16. Less absurd. Let's say that. So for this one, the answer is 9,500,406.338. And for this example, just put like centimeters squared. And then for this one, it's from pi to 16, since we're going over the x-axis. We're revolving around the x-axis, so over the x-axis, we're just consistently making a circle, thus creating a volume. And the formula for a circle, in order to find the area, is pi r squared, which is why we do pi times integration of r squared dx. This equals to Now this is a really big number, but that's what the area is. There is no specific units, so we don't know what it is. So it could be like millimeter squared, it could be anything. Moving on, we have the washer method. Now the washer method is in order to help you find the area of a cup, for example. Because for a cup, there's empty space in the middle, while there's a ridge out like what's it called? Rigid membrane like or outside of it. So essentially there's a inner circle right here. That's little r. Oh, and this is big R. And we're trying to find and for washers, we're usually trying to find the area right here, as this is empty space, so we don't factor into our thing. So in this case, our function big R right here, which would be this function, since the outmost function right minus left, we have the function of y equals negative 8.2x squared plus 7. And we have little r over here, which is represented by the function of negative 5.4x squared plus 7. And we're trying to find this area of r revolved around the y-axis. So our function, or our formula this time, would be pi times integration of r squared minus big R squared minus little r squared dx. And so for this one, it would be pi times integration from 0 to 7 of big R squared, so it would be negative 8.2x squared plus 7 squared minus little r squared, negative 5.4x squared plus 7 squared dx, which equals 2. Which equals to an area of 3,800 or 300,800, okay, 388,050.295. And this is the area of R revolved around the y-axis. And for this washer method, big R is represented by the function of y equals to square root of 2x squared plus 6. And then little r is represented by y equals 6x.